So our presentation today will be on quick part. Our team's name is obeam. I am Emmanuel Arsate. I am the actual recorder and spokesperson of the group.
I am Mohammed Hassan. I am the leader of the group.
My name is Odette Bryant. I'm the optimist of the group.
My name is Boubacar Tusu. I'm the analyst.
My name is Ayman Ali. I'm the pessimist.
Okay. So, I don't know if you remember, but from being a student at a college, you always have the dilemma of parking. So, I know that most schools here at North Carolina, like NC State, UNC Charlotte, people that I have like contact with over there have always had issues with parking. People always like complain about like paying a certain amount of money to be able to park somewhere, but then the dilemma is that you can't find parking anywhere. So I mean, some of the things that people are doing now to try to overcome that is, yes, they try to get to school early, they try to find parking spots, they'll circle around the parking lot to try to, find that parking spot that best fits their needs. So I mean, I got a question for you. How much time have you spent looking for a parking spot?
I'm usually early, so for me it's not a big deal, but when you come between the classes, it's going to be very hard to find parking slots.
So another thing that has been a growing dilemma as well is the fact that the number of automobile operators has increased significantly over the last few years. So one of the things that has actually caused is like the environmental impacts. If you go to the next, time is also wasted very often by trying to find parking spots. This is a diagram of a representation of how many drivers have increased in the year. So if you look at 1970, that's when the actual the biggest margin started to grow. Because from 1970 there was 545 people per 1,000 people driving vehicles, but in 1980 it grew up by about 210 people. So now we're at 2009 and just about everyone has a car. Now, what obeam, what our objective is to pretty much design a system that will allow users to find parking spots in an efficient manner, and in a quick and easy way to actually find those parking spots. As far as the research that we are doing now, we have came across two main solutions, which one of them involves sensors as using that method, and another method is actually the vision-based method. So we are doing ongoing research to figure out which one is going to be the best one.
What I discussed in this particular section is the background. What we did is research on 3 different areas. We looked at technical papers that existed regarding the topic that we were discussing. We also looked at the patents that were also available that are similar to the products that we're trying to incorporate in our project. Also, there are commercial products as well, things that are already on the market, is where we did a lot of our research. One of the papers that I researched was Smart Parking System. It was an architecture that was using ultrasonic detectors to figure out if a car was located in a particular spot. There were 2 different methods that this particular paper discussed. They discussed a sensor-based method and also a vision-based method. The sensor-based method is a great method for reliability, and also the vision-based method has some issues. The system-based method actually can check each individual space and make sure that there's a car there or not. And it can input data as far as a 1 or a 0 to indicate whether or not there's a car there or not. The dilemma with the sensor-based, or one of the disadvantages or the limitations, is that you have to incorporate these in each individual space. So for a person who is going to be installing this, it may become cumbersome. The vision-based method, it actually looked or use a camera to take a picture of the entire area using digital image processing. So it used one unit as a sensor to detect a number of cars in a particular area and use that same information to relate to your system. The limitations with the vision-based system is the fact that you have a lot of variables that you can't control. one being weather, one being cloud cover, and other issues that may come up with the color of the car versus a car that may have a similar color of the background that you're pre-imposing your image over. The other paper that we researched was a new smart parking infrastructure, and this was also talked about implementation as well. This was a macro design level where they incorporated a few different systems to figure out how to solve a problem for a multi-populated downtown area. So in their design, they did an incorporative design where they incorporated different systems to make a larger system. They utilized RF micro devices, or RF devices rather, to tell where the car was, where a car is going to be, and use that to figure out where's the best possible place to put the driver for their vehicle.
Okay.
So you're not in video,
Yes.
Two patents that we found that were related to our project was U.S. Patent 834778B2, the parking spot locator. The inventors of this patent created a way to locate available parking spaces. They use side pointing sensors along with GPS on moving vehicles to find available spaces in between cars, as well as they use sensors on other traffic devices to find out if a car was in that parking space. They also ask the users to voluntarily broadcast whether or not their parking space will become available. And that would be one of the disadvantages to this patent because it lowered the accuracy of the locator. Because if the user didn't volunteer that information, then that information would not be in the database. And the other patent related to our project would be U.S. Patent 20080024324A1. Method systems and computer program products for implementing a locator service. The inventors of this patent created methods that use object and location identification information, and they also they would take that information and upload it into a centrally maintained database. And these methods also included creating an occupancy record database, as well as collecting fees from the users. And the disadvantage to this patent is that the users would have to purchase a device to utilize their systems, and we wouldn't want the users to have to pay any extra cost to use the service.
So we are going to talk about the commercial products that are on the market. There are many, but we are going to talk about only two. The first one is MQB Park Assist. So this system uses digital image processing, so it uses cameras which are CMOS 5 megapixels. So they use a camera on the ceiling, so each camera can detect like 4 different parking spaces, and they have LEDs that will tell the different colors if there is a car or not. The second one is the Red Storm parking guidance system. This one, what it does, it just counts the number of available spaces, then display it on LEDs at the entry of the parking. So actually, the second one is not telling you like where is free or where you are good, but just telling you the number of the available spaces. Okay, so we are going to talk more about the MQB. Like I said, it's used DIP processing. So when it sends the actual image, it sends it to a central monitoring, and they send it via the Ethernet. So when the digital image processing is done, then each location is going to be like divided. I mean, each camera will be divided like in 4, so telling which one is available, and this guides the user by using what they call Find My Car toward which is available or not. So the limitations here are they use wires. So if they use wires, then wires are going to be challenging. And the advantage of this is giving you the location of your car, and it can give you the advantage to, even if you like give more money, then you can make reservations. The second one is the Red Storm. This is kind of basic because it's just telling you how many, but you have to drive around to find the space. So it's use a real-time LED display to tell you, okay, second level have like 5 parking, but you have to drive over there to find the parking. So it's use a sensor-based contrast, or it's use a loop detector to count when the car coming through. They're gonna tell, okay, we increased by number 1. When the car is out, it's decreased by number 1. Its limitations are, it's not really giving you, like I said, the number of, the location is just giving you the numbers of the parking. Okay, so you say objective 3. Here we're going to have a comparison of the marketing requirement, and we use AHP comparison. As you can see, have reliability, immunity waiver, accuracy, and user friendliness. Those points that we see there are the importance, like the percentage of the importance of each. So reliability and accuracy, we give them more importance than immunity to weather and user friendliness is easy to use. So for the reliability, we give like 2 points. We say, okay, since it's going to be outside, so we want it to be really strong because of the wind and all the other. And they want it to be able to process a lot of data, say like 800 or 900 data, like users can access it at the same time. So we want it to have protection because of the weather, and they want it to be operational in a given interval or given range of temperatures. Also, we want it to be really reliable, or not reliable but accurate. So say that if it tells you that we have 5 spaces, we are sure that it's accurate about those 5 spaces. And they also want it to find the space really quickly. You don't want to spend your time trying to load the space. And they don't want it to overlap, so we don't want it to give 2 different information that are overlapping. And they want it to be easy to use.
Now we move to schedule requirement. It is the requirement to convey details of customer problem to developer or designer. In our specification requirement, as you can see, the system must be maintained regularly, and also the system should be accurate to detect motorized vehicle such as car, trucks, or motorcycle. Also, the system should be immune to the outside elements. We can move on. In our level 0 block diagram, as you can see, the user request is to locate a parking spot according to which parking lot the user prefers to park at, and this as the input, and also the lot data is the number of the available parking spot, and this is our conclusion.
So in conclusion, what we want to talk about is the problem that we're facing. One of the problems that we're facing, as Emmanuel discussed earlier, is that people have a hard time finding parking spaces. So what our goal is to do is to make sure that we can devise a system that's going to alleviate these whole situations. The problem also that you find with not finding a parking space in time is the time loss. And everyone knows that when you lose time, you actually lose money. A lot of companies lose a lot of productivity if their employees aren't able to come to their place of employment and begin their work on time. We did a lot of background information regarding the technical papers, patents. We also discussed some of the market of probably actual devices that are on the market currently. What we've come up with is a solution to this problem. And the way we're going to come up with a solution to this problem is that we're going to design a system that takes into account all the needs of the user to make sure that we can definitely find a solution to this problem. The first way we're going to do this is identify the lot occupancy by whatever means that we have to find those, whether it be visual-based system or a sensor-based system. Our system that we devise is going to provide the user the most accurate, the most dependable information that they can attain at that particular time.